Remember when we were kids at birthday parties when we would try to stick balloons to the walls? We would see how many we could get stuck to the wall and how long they would stay there. We would take the balloon, rub it against our heads, and then try to stick it to the wall. And in the process, our hair would get stuck to the balloon and follow it and stick out in all sorts of places. We were told that this was called static electricity. But what is static electricity, and why does it occur? What's going on chemically that allows the balloon to stick to the wall and our hair to stick to the balloon? To better understand this, we're going to do another similar experiment. We're going to take the balloons, rub it against our head, but we're going to bring it close to a plate of salt and pepper and try to separate the pepper out from the salt. To better understand this, we need to know what this salt and pepper and the balloon are made of. Everything in this world is made up of atoms that are bonded together to form molecules and compounds. These atoms have negatively charged electrons and positively charged protons. Just like with a magnet, opposites attract, so the negative charges are attracted to the positive charges, and the force pulls them together, which helps with bonding. But if this is the case, and all things in the world are positively and negatively charged in some way, then why aren't they being attracted to each other and trying to be pulled together? Take a look at this salt molecule. It is formed by bonding a positive sodium ion with a negative chloride ion. While the molecule has both positive and negative charges, generally the quantity of these charges equals each other, balancing out the molecule and giving it no net charge, making it neutral. The same goes for the pepper and the balloons and everything else you see around us. All matter has these positive and negative charges, but generally the quantities of these charges match up and are equal and balance out, making everything have no net charge. This is why objects aren't trying to be pulled together by opposite forces. But if that's the case, then how does the balloon stick to the wall? If everything is neutral, then it can't be attracted to each other. That means there's no force pulling the balloon to the wall or pulling our hair to the balloon. So how's that going to work with the salt and pepper? This brings us back to the action of rubbing the balloon against our hair. When we rub the plastic of the balloon against our hair, electrons are ripped from the hair and attached to the balloon. The extra electrons on the balloon cause the balloon to be negatively charged, and the loss of electrons from our hair cause our hair to be positively charged. So, when we rub it against and we pull away, the positively charged hair is attracted to the negatively charged balloon. That's cool, and that explains how the hair gets attracted to the balloon, but it doesn't really explain how the balloon's going to pick up the salt or the pepper. Just because the balloon is negatively charged doesn't mean the salt and pepper are. They still have no net charge, so how are they going to be attracted to the balloon? Well, think back to before when we were discussing the salt molecule. Although the molecule has no net charge, they still have positively charged protons and negatively charged electrons. The charges are still there, they just equal one another. So when the negatively charged balloon gets closer to the salt and pepper molecules, those negatively charged electrons are repelled. They don't want to be near the negatively charged balloon. And they leave a positively charged area of the molecule. Think of it as two sides. The balloon gets closer with its negative charge, and the negatively charged electrons want to get as far away as possible, so they move to the other side of the molecule, while the first side of the molecule closest to the balloon becomes positively charged because of the lack of electrons. So this positively charged side of the molecule then becomes attracted to the balloon and gets picked up by the balloon. That's how the salt and pepper will be picked up by the balloon. Then how can we use this to separate the pepper from the salt? If both molecules are going to be attracted to the balloon at some point and be picked up by the balloon, then how can you separate the two of them? Well, that answer lies within gravity. While salt and pepper molecules seem very similar in size, pepper grains have a slightly smaller mass than salt grains. So the balloon can be a little further away from the plate and be able to pick up the pepper molecules, but not the salt molecules. So as you get closer, the balloon will start picking up the pepper molecules. But if you eventually get closer to the plate, it'll pick up the salt molecules too. So you kind of have to find the happy medium where the balloon can pick up the pepper, but not the salt. So let's take a look at how that works. We rub the balloon against our head. We have our salt and pepper here. We bring it somewhat close, and you can hear some of the molecules start to jump up. And when you look at the balloon, it looks like it's mostly pepper flakes. works. But if we get a little bit closer, and now we look at the balloon, you can see that there's more salt and pepper on the balloon. So it works both ways. Now, this may not always work. It usually works with the plastic rubbing against the hair or a woolly type material. If you have some hair products in your hair, that could prevent some of the molecules or electrons from being ripped from your hair. So that's why sometimes when you rubbed the balloon against the hair, it didn't stick to the wall as well as you hoped it would. Generally, when you rub the balloon against your hair, it causes the electrons to jump to the balloon, making the balloon negatively charged, which allows it to pick up these molecules because the positively charged sides are attracted to the negatively charged balloon.